Welcome to Learning with UNP. In this session of Data Science and Mastering Machine Learning, we are going to understand about K nearest neighbors. That includes understanding about what is KNN, working of KNN, example of KNN, distance metrics in KNN, key characteristics of KNN, choosing the value of K, and finally understanding about the pros and cons of KNN. We will also work on two projects implementing KNN. Let's begin with understanding about what is KNN. KNN is one of the most basic yet essential classification algorithms in machine learning. It belongs to supervised learning domain and finds intense applications in pattern recognition, data mining, and intrusion detection, etc. It is also called a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the dataset and at the time of classification, it performs an action on the dataset. KNN is non-parametric algorithm, means it does not make any assumptions on underlying data. KNN algorithm can be used for regression as well as for classification, but mostly it is used for the classification problems. KNN algorithm assumes the similarity between the new data and available data and puts the new data into the category that is most similar to the available categories. KNN algorithm at the training phase just stores the dataset and when it gets the new data, then it classifies the data into a category that is much similar to the new data. Let's now understand the working of KNN. Step 1. Select the number k of the neighbors, means choose how many nearby data points or neighbors to consider when making a prediction. Step 2. Calculate the distance metric of k number of neighbors, means measure the distance between the new data point and each of the k nearest existing data points using any of the distance metrics. It can be Euclidean, Manhattan, Minkowski, etc. Step 3. Take the k nearest neighbors as per the calculated distance. Means identify the k data points that are closest to the new data point based on the calculated distances. Step 4. Among these k neighbors, count the number of data points in each category. Means for each category, count how many of the k nearest neighbors belong to that category. Step 5. Assign the new data points to that category for which the number of neighbor is maximum. Means the new data point is classified into that category which has the highest count amongst its k nearest neighbors. Step 6. Our model is ready. Means the KNN model is now prepared to make predictions based on the defined steps and chosen neighbors. Now let's understand KNN better using an example. In this example, we will determine into which category the new data point belongs to. The two categories that we have are recovered and not recovered. The graph has x-axis and y-axis, in which x-axis shows age and y-axis shows resting heart rate with the values mentioned. As per our objective, we will start solving it. Here, we use the k value as 3 to predict the recovery of a person with age 87 and resting heart rate of 70. As you can see on the screen, with the three closest points, it shows that 2 belong to not recovered category and 1 belong to recovered category. Since the maximum data points belong to the category not recovered, we can predict that the person falls into not recovered category. Thus, this visualization gives us a good prediction. Now, let me tell you in detail what are the distance metrics used in KNN. First comes Euclidean distance. It measures the shortest straight line distance between 2 points. In this distance, we consider 2 points x and y in n-dimensional space. Subtract the coordinates of y from x. Square each difference, sum them up, and take the square root of the result. Second comes Manhattan distance. It measures the distance between 2 points along grid lines. In this distance, for 2 points x and y in n-dimensional space, subtract the coordinates of y from x, take the absolute value of each difference and sum them up. Third comes Minkowski distance. It is a flexible way to measure the distance that can act like Euclidean or Manhattan distance depending on a parameter p. When p equals to 2, it's like Euclidean. When p equals to 1, it's like Manhattan. This is a generalized distance metric. For 2 points x and y, subtract the coordinates of x and y. Take the absolute value and raise it to the power of p. Sum them up and then take the pth root of the result. We also have other distances like Hamming distance. in which Hamming distance counts the number of differences between two strings of the same length and they are used to compare categorical data. Now, let's move on to understanding the characteristics of KNN. First comes nonparametric. This method does not assume that the data follows a specific pattern or distribution, making it flexible for different types of data. Second comes instance based. It is a method where the model does not learn a general rule or pattern from the training data. Instead, it memorizes the training data and make decisions by comparing the new data points directly to the stored examples. Third comes distance metrics. It uses metrics or measurements like Euclidean distance, Manhattan distance, etc. to find the closest points for classification. Fourth comes choice of k. You need to choose how many nearby data points or neighbors to consider when classifying a new point. Fifth comes versatile. It works well with numerical data like heights or weights and categorical data like colors or types. Over here, let me tell you the ways or methods to choose the value of k. There are four important ways or methods to determine the value of k. First method is square root rule. In this, we select k as the square root of the number of data points in the dataset to balance reliability and manageability. Second method is based on data characteristics. In this, we use a higher value of k because if data has many outliers and noise, it is used to achieve more stable predictions. Third method is based on odd values. In this, we choose odd values for k to avoid ties in the classification decisions. Fourth method is cross-validation. In this method, we use cross-validation to test different k values and find the best one for the dataset. Finally, let's look at the pros and cons of KNN. Advantages or pros of KNN are it is easy to understand and implement. It makes no assumptions about the data distribution. It easily adapts to new dataset or small dataset. It works well with both numerical and categorical data. There is no need for training phase, making it faster to set up. Whereas the disadvantages or cons of KNN are it requires significant computation for large datasets. It needs to store all the data points requiring large memory. KNN performance can degrade with irrelevant features. Determining the optimal value of k neighbors can be tricky. The performance can be affected by the scale of the data, and it is sensitive to noisy data. This is all about today's lecture. See you in the next lecture. Thank you.